Now we're looking to solve equations which are not equal to 0 on the right hand side, and what we do here is we calculate something called the complementary function, and that's the general solution when like this left hand side is equal to 0. Okay, so we've shown how to do that before, and then what we do is we find something called a particular integral. Okay, and this is essentially a trial and error, and depending on what our f of x is, we essentially guess different specific functions that we think might solve this equation, and then we substitute them in to here to find the coefficients that we might need, and then our general solution for this whole equation is the complementary function that added to the particular integral, you see, because this is a particular solution. Okay, this gives us one solution that we want, and then the general solution when the left hand side is equal to 0, well, if you add that to a particular solution, you've got another solution, and the reason you know it's a solution is because this function substituted into left hand side is equal to 0, so it hasn't changed the value of what's on the right hand side. Okay? So first we're going to look at the trial function. So if f of x is just a constant, then we just trial a constant and we call that k. Ax plus b, where a and b are functions, then we try k1x plus 2, and these trials usually work. If they do, we've got a few techniques. Sorry, that's supposed to be a x to the n plus b x to the n minus 1. This is just an extension of that second one. But you see and then if we got a to the e to, then we'll say mu x, then we put in a1 e to the mu x. To find mu, we'd know mu. Okay, that was, so we had 7 e to the 2x, we put k1 e to the 2x, and we're just trying to find the value of k. But this will be a little bit clearer when we look at an example. So a cos omega t plus b sine omega t, and bear in mind a or b could be 0, so we still try the same thing if we've just got a function of cos or just got a function of sine as our f of x. We put k1 cos omega t plus k2 sine omega t. Okay, so that's it essentially for our method. Now we will look at what we're doing for each. Of x equal to 4x plus 1, and we're going to use on this left hand side something we've already used when looking at homogeneous equations, so that we just have the solution, we don't go through that again. Come on. Looking at something we've done before, we're going to take minus 6 and then plus 9y. Okay, so we've solved this before. If you saw our solution, the general solution of this when equal to 0 is y is equal to e to the 3x a a plus bx. Okay, so now a particular function, well, we've got, this is in the form ax plus b, so we are going to trial y is equal to k1 x plus k2, and now we're going to substitute this into this equation to find the values of k1 and k2, which make this y a solution to this equation. Okay, so dy by dx is equal to k1, and k2 or x is clearly, I'll substitute that in. So substituting it in here, we get 1 over 0 minus 6 k1 plus 9 k1 plus k2, and that's equal to 4x1. Okay, now if we look for our constant terms, we've got 9k2 minus 9k2 minus 6k1 is equal to, and then for our x terms, well, we've got 9k on the left hand side, k1, sorry, 9k1, and we've got 4. This basic idea, you should be familiar with equating coefficients. The constant coefficients and the x coefficients have to be equal, and the x squared coefficients have to be equal, and so on. So now we've got simultaneous equations, pretty easy solve. This k1 equal to 4/9, and then if you substitute that in here and solve for k2, you get that k2 is equal to 11 gs, general solution, which is the complementary function added to the pi. So y is equal to e to the 3x a plus x plus 4/9 x plus 11 over 27. To find a and b, we'd need initial conditions, which we don't have, but I hope this cleared up how to do it. We'll maybe do a few more examples with different functions on the right hand side. But for now, that's it. I hope this video was helpful. If you did enjoy, please like and subscribe, and I hope to see you in the next one.